Okay, guys, welcome back. Today, we're going to talk about dominance matrices. And I really wanted to come up here to the syllabus for this because really so far, a lot of what we've been doing has been more like revision than anything else. All skills you might need in the exam. But if we have a look at what the syllabus says specifically, the external examination may only assess on dominance and Leslie matrices when it comes to applications. So for our applications of matrices, we want to model real life situations using matrices, including dominance. And then tomorrow's lesson, if we have a look, if we kind of fold this out, tomorrow's lesson is going to be on Leslie matrices. So the dominance matrix allows us to do is to rank or order teams or individual players based on some kind of event. We typically think of this in terms of sport. So let's say I have like the NRL ladder. I might have, let's say I've got the Broncos, I've got the Titans, I've got, let's just do the Storm, and let's just pick the Roosters because why not? So these are my 4 rugby league teams, and I might have a situation where the Broncos beat the Roosters beat the Storm, the Titans also somehow managed to beat the Storm. The Storm must all be completely injured. And then let's say the Broncos lose to the Titans. So I have something like this, and this is what we call a dominance network. You can see there's a picture like this over here for 4 things as well, but I think it's kind of easier to see this in the shape of a rectangle. So there's my 4 teams. I've got Broncos, Roosters, Titans, Storm, and the arrow kind of points at who beat who. So here we could say the Titans dominated the Broncos. The Titans also dominated the Storm. The Broncos dominated the Roosters, and the Roosters also dominated the Storm. So from this, you might be able to see, okay, well, the Titans beat 2 teams, so they're going to be ranked 1. So we could rank this as being 1 Titans. The Broncos beat 1 team and also lost, so 2 can be Broncos. Roosters also beat 1 and lost, so it's going to be a tie for Broncos and the Roosters, and the Storm lost to everyone. So in this case, they're going to be the 4th placed team out of those 4. I'll put a little S for Storm. So you can see from like a network, we can kind of get an idea. There's 2 issues with our dominance network though. Issue 1, which of these 2 teams is better? Because it doesn't make a whole lot of sense putting them on the same ranking when the Broncos actually beat the Roosters. The Broncos also never got to play the Storm. So if the Broncos played the Roosters and the Storm, they might have also won 2 games. So maybe the ranking should actually look like, well, instead of just doing it based on wins, because the Broncos dominated the Roosters, maybe it should be 3 Roosters and 4 Storm, possibly. So this is kind of where our dominance matrix can kind of help us make sense of our little network we've developed here. But the network's a good thing to consider. And a lot of these questions will have some kind of network normally as part of the question, especially in the textbook. It also, we might find when we look at this that actually, you know what, the Roosters maybe are on par, or maybe I got this completely wrong. And maybe the Titans aren't the top team. Although in this case, it's quite clear the Titans are the best because they beat both the Broncos and the Storm. And just to kind of tie all of this conversation to notation, we typically refer to a dominance matrix as D. I said before when I was ranking between the Broncos and the Roosters that the Broncos beat the Roosters and they also didn't have the chance to play the Storm. So one of the things you talk about is second order wins. And a second order win is the idea that, well, the Broncos beat the Roosters, who beat the Storm. So therefore, really, this win against the Roosters should be worth 2 points instead of being worth 1 point. Sort of one of the ideas we talk about. So the way we notate our second order wins is we call this D squared. And if I do D to the power of 3, that's going to be third order wins, which means I beat a team who beat a team who beat a team. So really I get 3 points for kind of that type of victory or that type of event. Now with 4 teams, I feel like it does kind of make sense and sort of see how that works. But again, if I put 20 teams, or if I have like the NFL, which is 32 teams, for example, then this can get really, really complex, this dominance matrix, if, you know, we're logging this for a 16, 17, 20 week long season. So just in terms of notation, D for dominance matrix, that tracks what we call first order wins because it's power of 1. So it's just who beat who. D to the power of 2 is second order wins. So did you beat a team who beat another team? So therefore you should kind of get rewarded more for doing that. And again, if I have D to the power of N, that's going to be nth order teams. So that's, you know, I beat a team who beat a team who beat a team who beat a team type of ideas where things can get a little bit complex. Just note as well when I'm calculating these, because sometimes, like, for example, if I just calculate wins, so if I just look at my D column, then my rankings would look like the first scenario, which would look like this, where it'd be Roosters and it would be Broncos being tied, because they each beat one team. So who beat who? Well, if I look at first order dominance matrices, 2 wins to the Titans, 1 win to the Broncos, 1 win to the Roosters, and 0 wins to the Storm would give me a tied second and fourth place. If I now add this to my second order wins, then I would give the Broncos the extra point for beating the Roosters, who also beat the Storm. So my rankings would look like this, which you guys might think, hey, that makes more sense, because how could the Broncos and the Roosters be tied when the Broncos beat the Roosters? That's true for a lot of ladders. If you do like a ladder system for rugby league, even if you're going to tie, they'll take into account, maybe it's for and against rugby league. Some sports, they do like the head-to-head. So when these two teams played, who actually beat who, that would decide who goes first and who goes second if we have a draw. But I might say that, the Broncos beating the Roosters, who beat the Storm, they shouldn't actually get 2 points, because 2 points is a little bit extreme. Actually, if the Broncos played the Storm, maybe there was some injuries here, which is why the Roosters beat the Storm. It actually isn't guaranteed the Broncos would beat the Storm in this example. So maybe I don't want to consider my second order wins as highly as I consider my first order wins. So I can scale my second order wins as I like. I might decide that this is worth half as much as a first order win, or it's worth a quarter as much as a first order win. You're pretty rarely going to need to decide on what fraction you want to give your second order wins, but just note that normally when I'm doing my ranking system, we normally do at least D plus D squared. And some questions might have D plus a half D squared. Normally the question will specify how they want you to rank or order their players or their teams. So it can take a few different forms. Again, I could also add, third, fourth, fifth order wins, and maybe this would have some kind of fraction as well, or maybe some rule like 1 over n, d to the n. So if I was looking at fourth order wins, it'd be 1/4 d to the power of 4. So sometimes I might want to, weigh each of these individual events, less highly. So maybe in this particular sport, just wins is king. And then we want to consider second order wins to give a little bit of context, but it's half as important as my first order wins, just as an example. Now, hopefully this makes a bit of sense. I'm a big sport fan, so to me, I feel like this makes perfect sense. But if you're not that into sport, maybe we're a little bit confused. Maybe we don't even know who the Titans, Broncos, Roosters, and the Storm are, which is totally fine. Let's just look at how we can use matrices specifically to do this process. Because right now, we're just looking at a bunch of arrows and kind of drawing conclusions. Let's look at a more mathematical approach to get my ranking system. So here is my example. I have 5 friends, Anne, B, Kat, Deb, and Eve. They competed in a round robin tennis tournament where basically everyone kind of plays each other. And the results were as follows. You can see here on the right-hand side, I have my dominance network, and you're welcome to use this to help build your matrix, but we're also given like a written explanation over here on this side as well. So we have a written explanation, we have the dominance network. We can either combine these two to help us figure out what my matrix looks like, or I could use one or the other. I actually quite like the written explanation personally, so I'm going to go for the orange box when I explaining how you could form this matrix, but it's the same idea if I look at my dominance network. So the first step is to construct a one-step dominance matrix. That's D. And then part B is going to be to construct D squared. So first I'm going to construct D. So let's draw my matrix. Okay, so let's construct my matrix. Let's just put some letters on the side here to help make this make a bit of sense. I have Anne, B, Kat, Deb, and Eve. On the top, I also will have Anne, B, Kat, Deb, and Eve, which means my matrix should look something like this. Okay, so I essentially want to put 1s and 0s inside my matrix, where a 0 is a loss or they never played. So 0 is either a loss or they didn't play, and a 1 would represent a win. So Anne defeated both Kat and Deb, so I'd give this a 1 and this a 1 here. I don't know if Anne played B or Eve yet. I haven't kind of figured that part out yet, or who won in those particular games. I do know that Anne can't play Anne, so this is definitely going to be a 0 inside here. Now, if I look at B, B defeated Anne, so we get a 1 here. If B defeated Anne, then Anne also lost to B. So I can put a 0 up here for my B column. B also defeated Kat and also defeated Eve. And I'm not told about the other two boxes just yet. So Kat defeated Deb. I can put a 1 here for Kat defeating Deb. Also, I can put a 0 here again because B can't play B. And I can put a 0 here because Kat can't play Kat. I actually go ahead and continue putting zeros in. So you're going to find I normally get zeros on this kind of leading diagonal as I go through my matrix. This is going to be very common for a lot of these dominance matrices. Because again, Deb can't play Deb. Eve can't play Eve either. So I keep going through. Deb defeated B. So Deb defeated B. I can put a 1 here. If Deb defeated B, that also means that B lost to Deb. So I can put a 0 here on my B column. If Kat defeated Deb, I can also put a 0 here for my C. And if I do Eve, Eve defeated Anne, Kat, and Deb. So Anne, Kat, and Deb, which also means Anne lost to Eve. So Anne lost to Eve, Kat lost to Eve, and Deb also lost to Eve. So I've got a few boxes missing here. Really, as long as I kind of count my wins, I can fill in the rest. I might have even been a little lazy and missed a few here. Has Kat played? Oh, Kat and Anne have played, sorry, because I've got a 1 here. So Kat and Anne have played, so I put a 0 here for Kat. Kat and B also played and B won, so I should put a 0 here for B. Deb and Anne played. You can say I've got a 1 here. So Deb and Anne have also played, which gives me a 0. And Eve and B played and B won. So I also get a 0 here. I'll just get rid of my highlighters. So there we go. I filled that in nice. It's good to check that way. Ultimately, though, I can just put 1s in the wins and 0s everywhere else. That's kind of how this worked out, right? Anne beat Kat and Deb. So I get 1s there. I get 0s everywhere else. B defeated Anne, Kat, Eve. I get 0s in the other spots. So you can essentially put 0s there. It is good to kind of think of it the way I sort of, tried to explain it, because I think that can help kind of identify little errors or little mistakes. But ultimately, we're going to get a matrix with a lot of 1s and a lot of 0s. And I should always have 0s here on my leading diagonal as well. It's kind of one of the key features of this matrix. So this is what D is equal to. So I've constructed my one-step matrix based on my information. Now, something that's good to know, I can rank them based off my one-step matrix. So I can just basically count up my points. If I go across column 1, I've got 2 points. Column 3, I've got 3 points. Column C, I've got 1. D, I've got 1. And E, I've got 3. So right now, if I had to rank them, I would say Eve and B are tied. A is in 3rd place and C and D are tied in 5th. Or I guess 4th in this case would be how I would rank those. So again, the problem here is that I have a tie. So normally when I have ties, I want to do a second order matrix to help kind of shuffle it out and get some more definitive results. That's typically where my second order matrix comes in handy. It can sort of settle any ties. I've got a tie at first. I've also got a tie for last place as well. So let's do our second order matrix. To do my second order matrix D squared, that is simply just going to equal D multiplied by D, which is going to be equal to, let's actually just copy this to make my life a bit easier. To find D squared, that's going to be D times D, or it's going to be this matrix over here. As you can see, it's the same matrix multiplied by itself. Now, if I do some matrix multiplication here, well, I have 0 times 0, 0 times 1, 1 times 0, 1 times 0. So my first entry is going to be 0, and I'm going to keep just doing this as I go along. And again, I should basically get a lot of 1s and 0s again. If I do my if I row by my second column, well, that is going to be 0, 0, 0, 1, 0. So that's going to be 1. And if I keep going across like this, I get the following matrix. Okay, so if I continue doing that, I get this matrix here. If we rank these again, just for the sake of kind of seeing what happens if I look at my second order wins, then I'm going to get 2 for my first column. I'm going to get 2 plus 3 is 5 plus 1 is going to be 6, 1, 3, and 4. So if I look at my column like this, I now have B first, and then I have Eve second, which that might be okay. But I now have Anne being in 4th place and Deb being in 3rd place, which doesn't really make sense when I look at my first order wins over here for my D group. So to kind of make this make sense, I need to add D plus D squared to actually get a true ranking system. So if I have d plus d squared, again, I'm just adding my corresponding elements. So it's going to be 0 plus 0 be my first one. Then it's going to be, 0 plus 1. And then I'm going to do 1 plus 0. And then I'm going to keep on going. That's going to be 1 plus 1. So it's going to give 2. And I'm going to have, 0 plus 0 on the end here. So again, I'm just going to add my corresponding elements. I'm going to do that for every single row. And I'm going to wind up with this matrix here. So if I put my little letters on, this is my matrix. And again, if I go through and rank those, that's going to give me 4 points. It's going to give 6, 8, 9 points. It's going to give 2 points, 4 points, and it's going to give 1, 2, 4, 7 points here. So now, again, we've taken into account a little bit more context as to our results. I still have a tie. So if I really wanted to kind of settle this tiebreaker here, then maybe I change the weighing of second order wins, or maybe I do third order wins and do a D cubed column. The question just asked me to do D plus D squared. So I'm going to rank my 5 players in first place. In first place, I'm going to have B. Second, I'm going to have Eve. In third, I'm going to have Anne and Deb. And in fifth, I'm going to have Kat. That's going to be my rankings. Hopefully this made a little bit of sense. It's actually not overly challenging to design or set up these dominance matrices. It just takes a little bit of time and effort to kind of read through. Obviously, it can be a fair bit of writing as well. And hopefully the theory makes sense as to kind of how this works.